Hello students, welcome to my channel CGAT Maths. Myself Dr. Suresh Brother. In this video, we are going to discuss an example on pedal equation. Pedal equation of a polar curve. Show that pedal equation of a polar curve r raised to n is equal to a raised to n sin n theta plus b raised to n into cos n theta. In this form, this is 2 p square into a raised to 2n plus b raised to 2n is equal to r raised to 2n. Okay. Let me go for step by step. Student, first to take, as usual, while finding the pedal equation or angle between two polar curves, we are going to find out, or we are going to take logarithm on both sides. Take log on both sides. So what is the working procedure to find out pedal equation, student? First we have to find out either phi or cot phi. Phi explicitly, this is implicitly. If you get explicitly, use p is equal to r sin phi. Otherwise, can use 1 by p square is equal to 1 by r square plus 1 by r 1 by r square plus 1 by r square into dr by d theta whole square, or 1 by r raised to 4 into dr by d theta whole square. Okay. So then we are going to eliminate theta from the given equation and this equation. That is the pedal equation. So this is log of r raised to n is equal to log of a raised to n into sin n theta plus b raised to n into cos n theta. Friends, we cannot apply laws of logarithm here because of a sum. So you can differentiate directly. Differentiate r with respect to theta. So by differentiating r with respect to theta, or before differentiation, here just I am going to use only one thing. Log r raised to n is n log r. You write this term as it is. So this is n into log r is 1 by r into dr by d theta is equal to log means this is 1 by a raised to n into sin n theta plus b raised to n into cos n theta. So differentiation of a raised to n into sin n theta is a raised to n is constant, sin n theta is cos n theta. Again differentiation of n theta is n. So b raised to n is constant, cos n theta is minus sin n theta. Again n theta is n. Okay. Fine. This is n. This will become part 5, student, is equal to, so n is common here, we can take n outside, get a raised to n into cos n theta minus b raised to n into sin n theta divided by a raised to n into sin n theta plus b raised to n into cos n theta. So n and n get cancelled. Cot phi is equal to a raised to n into cos n theta minus b raised to n into sin n theta divided by a raised to n into sin n theta plus b raised to n into cos n theta. So after getting here, we'll get a what cot phi in terms of implicit notation, students. So for that purpose, we need to use, or we need to substitute cot phi in substitute cot phi in, students, we have P is equal to R sin phi, that is the length of perpendicular from pole to tangent. This is, you can square this one and take reciprocal. You'll get 1 by P square is equal to 1 by R square sin square phi. This is, keep it 1 by R square as it is, 1 by sin square phi becomes cosec square phi. So this is 1 by R square into cosec square phi is 1 plus cot square phi. Okay. So you can substitute here, substitute in 1 by P square is equal to 1 by R square into 1 plus cot square phi. Okay, fine. Okay. 1 by P square is equal to 1 by R square into 1 plus cot square phi. Cot phi is a raised to n cos n theta minus b raised to n into sin n theta divided by a raised to n into sin n theta plus b raised to n into cos n theta whole square. Okay, fine. So this is 1 by P square is equal to 1 by R square times of. So let us take an LCM, students. LCM is a raised to n into sin n theta plus b raised to n into cos n theta whole square is the LCM. You can make it separate, like that is a by b whole square can be written as a square by b square. Okay, so this is a raised to n into sin n theta plus b raised to n into cos n theta plus this is whole square. Okay, plus e raised to n into cos n theta minus b raised to n into sin n theta whole square. Fine. Okay. Now this is 1 by P square is equal to 1 by R square. Now we are going to expand by using identity a plus b whole square and a minus b whole square. This is a square. A square means a raised to n whole square is a raised to 2n into sin square n theta plus b raised to 2n into cos square n theta plus 2ab, 2 into a raised to n into b raised to n sin n theta into cos n theta plus a minus b whole square, a raised to 2n into cos square n theta plus b raised to 2n into sin square n theta minus 2 a raised to n into b raised to n into cos n theta into sin n theta. So whole divided by a raised to n sin n theta plus b raised to n cos n theta whole square. This is 1 by P square is equal to 1 by P square is equal to 1 by R square into one minute, friends. 1 by r square into, okay, this is plus 2 into a raised to n into b raised to n sin n theta into cos n theta minus 2 a raised to n into b raised to n into cos n theta into sin n theta get cancel. Okay. And you also observe, look at the first term and this fifth term. In these two, a raised to 2n is constant. You will get sin square n theta plus cos square n theta. Similarly, in the second and fifth term, b raised to 2n is constant or common. You'll get cos square n theta plus sin square n theta divided by, you just remember, students, what is a raised to n sin n theta plus b raised to n cos n theta value is? Just you go back and observe. Look at the equation. What is a raised to n sin n theta plus b raised to n cos n theta is r raised to n. So its value is r raised to n whole square. This is 1 by p square is equal to, look at this, 1 by r square into r raised to n into 2 is r raised to 2n into, this is a raised to 2n. This is sin square n theta plus cos square n theta by using first identity is 1. Similarly, b raised to 2n into cos square n theta plus sin square n theta is, this is 1 by p square is equal to 1 by, when base are same, powers are added, r raised to 2n plus r 2r 2 plus 2n into a raised to 2n plus b raised to. So we are at the final answer. Just you can cross multiply it, students. R raised to 2n plus 2 is equal to p square into a raised to 2n plus b raised to 2n. Okay. Or write in the reverse order. This is the required pedal equation of a given polar curve. Thank you so much for watching, students. We'll meet in the next video.